Hey folks, welcome back. In this video we'll be talking about Git, right? Now Git is widely used. Probably you would have used it at one point of time to even some of the basic commands, right? Like to do git clone, git pull, push, and all of that, right? Now in this video we'll not be mainly concentrating on these commands because you'll find a lot of guides out there or a lot of cheat sheets on what these commands will do for you. But I wanted to talk about a little bit about how Git actually works or functions, right, at the basic level. So that's going to be the most important part of this discussion, right? So we'll get right to it. So the first thing which you need to realize with Git is you need to understand, or you probably would have again heard of this before. We have something called So you have something called SHA-1 hash, right? This is nothing but a hashing algorithm, right? Which means I can provide any kind of content, file, directory, run a SHA on it, and it's going to give you a unique hash, right? So let's do that. Let's try that out. Right now, using one of the Git command, we can actually get the hash of any or SHA-1 hash of any of the content, right? So I'm going to do that. So I'm going to say echo, and let's say one of the superhero, which is Iron Man, right? I'm going to put Iron Man here, and I'm going to pipe that to Git hash object, and I'm going to say please hash the content which is provided as part of the echo, right? So there you go, right? So I've got a hash value here, right? You can see the hash value here. It's starting from F9, 5, 7, and so on, right? So a big hash value. Now you take the same thing and you run it on your laptop, you're going to get the same hash content. So a specific content or a specific text is going to have the same hash value no matter what. Okay, and Git basically uses uses hashes to store the various the content which is pushed into it, right? So at the end of the day, you'll be using Git to kind of store various code samples, or you will be using it to store some configuration templates, Ansible playbooks, and so on, right? So every single thing which you push into Git, right, it's stored as an object, right? And it's stored as an object in the Git repo. Now, right now, we have not initiated a Git repository, so we will not be able to see anything inside here, right? If I do a tree, right, you don't have anything. It's 0 files, 0 directories. So let's fix that problem. What we'll do is, also remember, this SHA is going to be unique, right, always. So for a specific text, this is going to be the SHA. For a different text, you're going to have a different SHA, right? Cool. All right. So I'll go with the first command, right, which is git init, right? And we'll investigate what this guy is going to do for us. So I'm going to initiate a Git repository in this particular directory which I have, which is called Git demo. Right now it doesn't have anything. There you go. I've initiated it. Now what do? Let's do ls and a and see what it has created, right? And there you go. We can see we have a .git directory which got created. Sweet, right? Now what we'll do is we'll do the same thing which we did earlier, right? Which is creating a hash for a text content. But this time what we are going to do is we are going to do this with a flag called write, right? So by doing that, we are basically telling Git to store this content in this newly created repository now. Okay, so let's go and do that. There you go. The content is still, the hash is still the same, right? Nothing has changed. It's the same hash, but yeah, that's good. All right, so we've got that sorted. Now what we'll do is we want to see the directory structure, right? So I'm going to say open.git, hope that works. Sorry, open.git, right? Okay, there you go. We can see the folder now. This is the .git folder. Think of this folder as the database of Git, right? Whatever you push into Git is kind of like stored here. This is like the database. And in fact, the most important part is the objects folder, right? And inside the objects folder, you see there is a very interesting folder starting from F9. Can you relate what this F9 is? If you see here at any of the hash, right, the hash which we just now pushed, it starts with F9, right? And the rest of the stuff starts with D5, 7, 3, or whatnot, right? So let's see. Let's go in. There you go, D5. So basically, you can understand now that Git is literally storing whatever we pushed, right? Inside this objects folder, it picks the first two characters as the name of the folder and the rest of the, SHA value as the name of the file. That's just an optimization mechanic, to instead of having like separate folders for every single, repo. Every single content, right? Now, in future, if we have one more SHA, which is starting with F9, we can push that inside this folder, right? Just an optimization technique. But other than that, you understood how we can also do a tree here to see everything, right? There you go. So we did a tree. Forget about this DS store file that just gets created on Mac. Let me just go and delete it probably, right? That's always there. But the most important thing is you need to analyze here the objects folder, and inside the objects folder we have the F9, and you can see the hash value, the rest of the hash value here, right? Cool. Now we can also see what is stored in this file, right? This specific file. I am expecting Iron Man should be there, right? Because that is the content which we pushed. So let's see what that is there. So for doing that, we can do a cat file, right? We have to use git and cat file, right? And what is the file name? Take the whole thing, right? Take the whole stuff like this, and you can put the pretty print. You can put the P flag, which is the printing flag, and there you go, right? It is telling me that it is the Iron Man, right? The content which we actually pushed. Now we can also, because in future we are not going to be we are in fact probably not ever going to use Git to just store content like this, right? We'll use Git to store files, we'll use Git to store folders and so on. So in that case, you would really want to know what is the object type of this file, right? Just like you have object-oriented programming, or in any programming you have some types, right? When you're storing some data in your program, you're going to use various types. Like in Python, it could be list, dictionary, string, and so on. Similarly in Git, right, you have each of these, whatever content you're pushing in, it has some kind of a type. So if you want to see that, you can just pass the T flag, and there you go. It's going to tell you that this particular content which we just now pushed, it's of the type called blob, right? And we will obviously come back to this. I'm just going to write it here so that we can recollect this later. But blob, right? It's basically nothing but the it's nothing but the type which is used to reference the content, right? It's nothing but this just directly refers to content, right? The content which you pushed into Git, right? So that is kind of like stored in a data. Think of it as a data type or database type, whatever. But that's what is called as blob. Sweet. All right. So that's good. Now what we'll do next? Let's I just wanted to use this repo just to show that, right? So now what I'll do is I'll go back. No longer interested in this repository. So I'll go to another repository or another folder which I've created called movies, right? So what is this folder having? Let's check that out. So let's do tree, and there you go. So what I've done is I have created a folder, right, with in fact, maybe let me see if I can open can I open the folder here? Yeah, to show you guys. Yeah, so this is what I have, so basically I have created a folder called movies, right? In fact, and inside that there are going to be two things. One is a text file called index, right? And let's see what is that in index. So I have in the index I have something called superhero. So what I'm trying to do here is I'm trying to create a small let's say version controlling to keep a track of the various interesting movies which I need to watch, right? And that's why I have an index file which will have the various genres, right, which I'm interested right now. I just have only one genre over there mentioned in the index file called superhero, and for every and then I have a folder called genre, right? That's what I'm showing you here. So I have a folder called genre. All right, give me a second. Let me clear out my screen. And okay, that looks good. Okay, yeah, so we've got a folder called genre, right? And inside that folder, I'm planning to create separate files for every genre. Like for example, I have one file for superhero. Right now, it's just saying superhero. But I plan to put all the movies which I want to watch, which conform to the superhero genre inside that, right? Maybe in future I want to add one more file for say action movies or political thrillers and stuff like that, so I can add more stuff. So this is just me creating a Git repository to track all the movies which I really want to watch, right? A simple use case. Coming back here, let me just clear the screen. Yeah, that looks good. So we are back here, and now that you have understood what the use case is, right, and this is the directory structure, right, we've got one index file and we got a folder called genre which will have separate files for every genre. Cool. So that being said, let's go to let's see what has happened. So do we have we don't have a Git here, right now. If you do tree, as you see here on the top, we don't have a Git initiator. So we'll go and initiate Git in this particular directory, and there you go. So as soon as you do that, Git will start tracking everything inside that. So we'll do Git Status, and it's basically telling me that there are few files which are not yet committed or which are not yet staged, and there is this junk file which, let me just remove, always gets created, but apart from that, I think will look good. So it's basically telling me these are the files which are basically yet to be staged, right? So this is the workflow generally which we follow in Git, right? It's a very traditional workflow. We first obviously do Git init, right, where we initiate the repo, then we add files to it, right? When I say add files or create files, right, think of that way, and then we stage it, right? So we are doing staging now. So how do you stage it? Pretty simple. So you do git add, and what's the name of the file? One is the index.txt, and the other one is git add the folder, which is the genre folder. There you go. So we have done with the staging part, and the last part is the commit part, right? Now these three items, right, which are here, these three items are something which you commonly do regularly. I mean, git init is something you do only once, but these three items, creating files, adding files, editing files, all of that you do. Then you do staging, and then the final part is the commit. So how do you commit? Git commit, right? And you can put some kind of a text, right, like a comment. So I'm gonna say first commit. All right, then that should be good. There you go. So it committed something. So it committed these three files, which is a good thing, right? So what we can do now is, let me just clear the screen a bit. So I'm gonna run what we call as Git Log. So this particular command will tell us every single activity we do inside the Git repo. And there you go. We've got some kind of a hash value. It's saying commit, and there's some hash value here. So I'm gonna just copy that hash value maybe onto my notepad or something here, right? So that we can kind of refer to this later. Maybe it's a bit small. Can I increase the size of that? Probably. There you go. Okay, so it's starting with 4A, 2C, whatnot, right? So let me go back here and let's go to the folder. Do we have the folder here? I think we have it here, right? So there you go. I can see my .git here. Let's go inside that, and inside the objects folder, and what was that again? Let's see, 4A. Let's see 4A. Can we search 4A here? Yes. There you go. Right? Even the commit is also another object which is getting created inside your Git. Right, so if you have to list this, right, so let me go back. Let's get rid of this. So what are the various objects? We have already seen one, right? The various objects in our Git are, the first one is obviously your blob, right? We talked about blob earlier. It's basically referencing the content. We have just now seen commit, right, which is also stored as an object, right? Think of commit as in a simplest term, think of it as a snapshot of your repository. Every time you commit in a repository, you're snapping it, right? You're creating a snapshot, for future reference. You're creating a history and you're snapping it, right? There you go. So that's a commit. We looked at commit. Commit also is nothing but, just like blob, commit also has its own SHA value, right? And when you look at that particular, when you look at the directory here, you can see that, the structure, everything is very similar to how blob was created, right? So we've got this. We've got a commit just now. We have committed something. All right. Now what we'll do is we'll get a bit creative, right? So we have seen how we can see the information which is stored inside a particular file, right? Referenced by the SHA. So how do we do that? We do git file, and we gotta obviously get this guy. We need to copy this one, right? So let's copy that guy, and let's do print, right? -p with the flag p. Okay, did I do something wrong? I think probably there was an error. Okay, there you go, right? So when you try to see what is happening inside this particular commit, right, you get to see a bunch of stuff. Now what do we see first? First is, let's go from bottom. So we have the comment which we added, right, as first commit, that is visible. We have the author and the committer's name, that is also nice, not an issue, right? It's information which is provided, right, to understand who committed it and all of that, so you can track everything. There's one more interesting thing which we see here, which we call it as tree, right? Now that's interesting. Tree, we have not seen what tree is before, all right, but before I explain what tree is, let me just add it here. Tree. So by this, I think you would have understood tree is nothing but another object, right? But what I mean by that is, if you go and search for this 0D7 whatnot, like on your directory here, you will find it, right? There you go. We have 0D7C. So even tree, right, also is nothing but an object. And what does tree actually refer to? Tree refers to nothing but, you know, a directory in Git, right? So let me now try to summarize everything. Blob refers to like the actual content, right? Like the actual text, right? Like Iron Man, superhero, whatnot, right? Actual text is referenced by blob. Commit is like a snapshot, right? It is basically like a reference to reference to a point in time, right? To understand what the directory looked like. And the tree is literally the directory, right? And we can understand this more. When I say snapshot, you see that this commit was referencing this tree itself, right? So commit is literally a snapshot of the directory, right, where your whole Git repository is residing, right? So in our case, because this is the first commit, you can see the commit is referencing just one tree, because commit can have multiple trees as well. We'll see that probably later, right? Can reference multiple trees. But now in this particular use case, because we did the first commit, our first commit is referencing the snapshot, which is nothing but represented by a tree, right, which is the full movies folder in our case, or the directory. So let's go and get creative and see what is happening inside this guy. So we'll do put the flag P, and let's try to see what is happening inside this directory, right? And you can see this directory. From this you can understand that it is nothing but our root directory, right? Because if you do ls, you will see genre and index.txt. That's nothing but referenced by our tree over here, right? So let's try to look at this from a picture point of view. That way, you know, you will not have much confusion. So let's get rid of that. So what have we done? We have started with let's represent commit here, right? So this is going to be commit. And for the commit, I'm going to use the first four numbers, which is 4A to C. There you go. So that's your commit. Then the commit is referencing two things. Let's go top. Sorry, the commit is referencing only one thing. My bad. The commit is referencing only one thing, which is the tree over here, right? So we'll grab a tree. Let's draw a tree. So there you go. That's a tree. And the tree is referenced by 0D7C. Okay, I'm happy with that. Now we also dug deeper into the tree. What is there in this tree? So the tree in turn, did we do that already? Let me see. Yeah, we dig deeper into the tree, and you can see the tree is basically having two things. The tree internally has one more tree, and then it has a blob. So let's first draw the blob, right? So the blob is basically the blue one. Let me reference it by a blue one here. And there you go. So we've got a blob, and the blob is basically EC25. I'm just representing the first four characters, right? And the blob is nothing but the index file, right? And you can see it is EC25, right? Just for your reference, what does index have? It has the text called superhero. Okay. Does it have like a? That's interesting. I did not know that. Give me a second. Let's see what this guy has. In the superhero. Okay, both of them have the same thing, so that's fine. Anyway, so what I was saying was in the index file we have the term called superhero, and I think there's a percentage as well probably at the end, but that's fine. Both of them have it, so kind of helps me explain my example. So we've got EC25, which is nothing but my this blob, right? Because like I said, blob is nothing but the content which is stored in a particular file. but it is also referencing a tree at the top. So let's draw that. So let's go up and let's draw this other tree over here, and that's nothing but A77AF, right? Awesome. Now let's dig deeper into that particular tree. So let's grab this guy. So we are just recursively trying to figure out or chart out the whole directory of Git, right, to understand this. So let's do that. So let's do print, and there you go. We can see there are two blobs which are inside this guy, right? There are two blobs, guys, and what are those two blobs? Let me draw the first one, which is the readme blobs. I'm going to draw it here. Let me just draw it using the black, and there you go. That's the first blob, and that has A0C8. That's good, right? So that's your readme blob. And what about the second one? Now, isn't this something which we saw already earlier, right? Didn't we? Let's look at that. Let's probably run that previous one again, right? That was the previous one. I think this was the previous one, right? Now observe this one. Observe the second blob, right? It's exactly same as the blob which was there here. What does this tell us? This tells us that Git doesn't create a duplicate of the blob, right? Since both the files had the same content, which is superhero, right? Both my index file has superhero and my genre superhero file also has superhero. Because of that, you can see that Git is kind of referencing, right, from this tree, it is directly referencing this earlier existing blob. It's not creating a new blob, right? Is that simple, right? I think I picked this example because I wanted to show you that, right? Because both the files had the same content, you can see that it is in fact referencing to the same blob, right? So if I have to complete this picture, let's do that. So you can see from here, we are coming from the commit, right? This is basically referencing nothing but the root directory of the whole, the root, Git directory, right? Which is like in our case, the movies directory. But once you come to the first tree, right, which is nothing but again the root directory, we have two things. We have the what did we have? We had the genre folder here, right, which is here, right? This was a genre, and then we had the index over here, index.txt, right? So that was the file which is referenced by this particular tree. And once we came down here, this was nothing but the content of the index file, right, which is nothing but the superhero, right? This guy was just referencing the content superhero. We came on the top, and here, once we came here, this guy was referencing readme file here on the top, and then this guy was referencing again superhero, right? In fact, sorry, it was superhero.txt, right? It was referencing the superhero.txt, which in turn had the content which was superhero, right? You can see on the left hand side, right? All of that is visible. Genre index, and then the readme and the superhero.txt on the top. That's same thing here. So this is how the whole Git kind of works, right? This is how it stores everything, and you can see all of that is visible from the objects folder as well over here, right? We can, how many objects do we have? We've got 1, 2, 3, 4, and 5. 3, 4, 5. Do we have 5 here? How many do we have? So we've got, let's just close this. 1, 2, 3, 4, and 5. There you go, right? So all the 5, objects are accounted for, and we spoke about it, right? Does that make sense? So that's literally how, Git kind of goes about storing stuff, in its, think of it as a database, right? Hope this example was useful. Just to recollect, commit is nothing but referencing to the, because it's the first commit, it's referencing to the tree, right? It will always reference to the tree, and the tree in turn can have other trees, which is, exactly this example, or it can have directly a blob, right? Because if it directly has a text file or something, then it is obviously referencing a blob, right? Or the tree can reference another trees, because if you have folders within the folder, then it's going to be referencing, another tree, which in turn can reference another blob or another tree, right? And other important thing is Git doesn't create duplicates. If the content is same, right, then really doesn't have a necessity to create a different blob, right? So it will reference to the existing blob. That way it will optimize and save space. All right, cool. All right, so now what I've done is I've just pushed this diagram a bit below, because what we'll be doing now will be very much connected to this. So what we'll do next is, let's look at this file which we have, right? We have the index.txt. Let's try to edit it, right? So we are basically going to, let's probably use something like a nano or something, right? Let's say index, and what I'm going to do is I'm going to add one more genre now, right? So let's say I want to watch action movies. I'm going to add one more genre called action, right? So I'm going to write this down, right? And there you go. So now the index file has something different. It has superhero. In addition to that, it also has action. Interesting, right? So what does this mean? Let's check our Git status, right? So if you do Git status, it's basically, okay, there's this stupid file. Let's just get rid of that, clear the screen a bit. But yeah, so Git status is basically telling us that, look, you have modified the index file. What does that mean? As per our workflow, every time you modify a file, we need to add it. So let's add git, right, to git add, and we'll say git add index. Great, we have added that file, and obviously we need to commit it, right? Just adding is not sufficient, we need to commit it. So I'm gonna commit it, probably add a comment saying that added action, right? That's our comment. Okay, so there you go. We have changed something, we have staged it, and we have committed the file as well. Cool. Let's go back and check the log. There's something interesting. Looks like we have a new we have a new, let's copy this, we have a new commit SHA1 scene here, right? So let's go back here and let's investigate what's in this. So we'll do cat file, let's put the p flag along with this guy, and there you go, we have something interesting here, right? So forget about, okay, this is the comment which we added, right, which is called add action, and we've got the author and the committer, which is fine, right? Which we saw earlier as well. But in addition to that, we have two interesting lines here. One is the tree line, and we have the parent line. Interesting, right? So for the, let's again go from down, right? So we know that this is the commit, right? We just now committed, and we are basically looking at the commit SHA. So we know that for sure this is the commit, this is a new commit. So let's add that commit here to our diagram, right? So let's probably add it here, right? There's a new commit, and that's nothing but F7165, or let's just put the first four, right? So let's get rid of that, right? Cool. But when you observe here, that commit is referencing to a tree. Okay, looks like this is a new tree, right? We do not have this tree, so let's probably put that, right? So let's add probably a new tree. Let me just grab a different color, maybe. Yeah, so let's add the new tree here. So where's the new tree? Let's put it here, and this is going to be the new tree, and the new tree is nothing but what is it? It's basically 3097, right? That's your new tree. That's fine. But in addition to that, it also has a parent. You can see this is the first time we are seeing this. It wasn't seen in the previous case because that was the first commit. But you can see now this commit, which we just now did, has a parent, and there's some SHA. But when you look at this SHA from the diagram, you can see it is nothing but this guy, right? The previous commit. So what does that tell us? It basically tells us that new commits always, they will be referencing to the previous commit. In our case, this is the second commit, the topmost commit which we did. It is referencing to the previous commit, which is the 4A, 2C, whatever is that, right? So that is referencing to that, right? So that's pretty cool. Now let's dig deeper more. So let's go to same thing, git cat file, but let's investigate the first tree, right? The tree. And when you see that, you see the tree is again nothing but very similar to this tree, right? The tree which we have here, but it's obviously a new tree. But in that tree, you can see we haven't done any changes to the genre folder, right? That is why it is still referencing to the existing genre folder, because there is no change. So Git is not going to create something new. So it's still referencing to this guy, right? Because this genre folder which you had earlier, right? The A77F33. That's why I have been writing the first 4 characters just for us to, refer, right? So you can see this guy is still referencing. Genre folder is still the same. There's no change to the readme file. There's no change to the superhero blob, right? So it's still referencing here. But the index file has changed, and that's why you see there is a different There's a different blob here, right? Earlier the blob was EC25, but you see now the blob is different. So I'll go ahead and create a new guy here, right? And this is gonna be the new index file. So obviously it's gonna be 7528, right? And this is nothing but referencing to the index.txt. This is nothing but now it is having superhero and it is also having action. That is why a new blob has been created, right? Got the point? So this is how, right? I wanted to really show this because this is literally how Git builds its database, right? I mean, initially you will have the first commit, you would add some files, you do a first commit. Now as and when people are adding more and more files, more and more changes to the code or whatnot, right, new commits will be done. So the new commits will always reference the previous commits, right? In our case, this is our second commit, we are referencing the first commit. But in addition to that, even in the new commit, once you commit, there might be some files which have not changed, in which case it will still refer to the older, older blobs or older trees, right? But if there has been some change which was done, then in that case, obviously a new blob will be created. And if that blob was part of a tree, then a new tree also will be created, right? What I mean by that is, let's say if we had changed the readme file, then because the readme file was present inside our tree, then this guy also would have changed. So that way you would have one more new tree getting created. But you get the point. Git is a very efficient that way, right? It's very recursive in nature. And keep in mind that every time you do some change, the corresponding blob and tree goes on changing, right? Unless and if you don't do any change, then Git will peacefully go and reuse the existing, blob and trees, and that way it keeps everything very optimal and doesn't recreate. Because in a big repository, you might have hundreds of files, right, corresponding to your big code or something like that. So you really don't want to waste space and make management difficult by creating repetitions or duplications of files, right? So duplicates of content. So that's a very interesting thing which Git does. All right, awesome. All right, so now next we'll talk a little bit about branches, because that's something which confuses people a lot, right? We've talked about commits, trees, and blobs, but where does this branches come in? What are these branches, right? That's very important. So to do that, what we'll do is let's go back and see let's clear the screen a little bit here on the left. Let's see what we have as of now. We've got this, right? Just one directory and 3 files. That's what we have. And in our Git log, we can see we have 2 commits which we are happy about. We saw that till now. What we'll do is we'll do and see what branches do we have. So we'll do git branch, and it's going to tell us that we have right now only the master branch. Okay, so we've got only the master branch right now, right, which is fine. That's all right. We've got only the master branch. And where is this visible on the directory? So let's look at that. So here in the directory, if you go to, let me just close all this for a minute, because I want you to observe this folder called refs, right? There is a folder called refs. So if you go inside this, there is a folder called heads, right? And there you go. You have the master branch, right? So what does this guy actually have, right? There is some kind of content which is something which Git is storing. Yes, we can see that from here. But what does it actually have, right? So we can just do that. So what we'll do is, before that, I want you to see the latest commit number, right? Or we already have the latest commit number here, right? So that's fine. So we can directly go and do a cat here. For what? We can do a cat for I think it's .git, and we've got refs folder, and inside the refs folder we have the head, and we can do master. Let's see what is that. There you go, right? So you can see the master file is nothing but a file which is referencing to the latest commit, right? Because we just have one branch as of now, and by default that branch is the master branch, and the master or branch basically is nothing but, so from this you understand that the branch is nothing but, it's nothing very fancy. It is just reference to the latest commit, right? So what I'll do is I will just get rid of this huge thing because I'll not have space to write. So let me give you a second. So let's just so okay, even this. All right, cool. So what I want to do here is, let me just try to draw again, but I'm going to just mention only the important stuff. So let's say we talked about the commit, right? We talked about the commit, the first commit, which was, what is the first commit? For that, we will have to again do Git Log probably, right? The first commit was here, 4A2C. That was the first commit. Then we realized that, the second commit, which was the one at the top, which is, I think, F716, was nothing but referencing to the previous commit. We had known this. And just now we realized that our master, right, which is the branch, right, is nothing but referencing to this guy, right? We realized that just now. So let me just quit this, go back. So the master is nothing but another, it's not a data object as such, it's a branch, right? But the branch is actually stored, the details about the branch are stored in this refs folder. And if you go and check there, if you do a cat and if you look at that, it's going to basically have the SHA, right, of the latest commit, which is the F716 in our case. So branch is just a reference to commit, right? Let's just on the top note down everything we have studied. So we have studied that blob is probably the smallest object, and this is generally referenced by a tree, right? A tree can reference another blob as another tree as well, right? That is also possible, right? But a tree is then referenced by a commit, right? It's all references, right? And then a commit is referenced by what? Just now we learned branch. So this is the flow, right? Branch, commit, commit to tree, tree to another blob, or tree to another tree, right? So that's what I wanted to show that. Cool. So that being said, so we are here right now, and this is looking good. So we are here and we realize. So what we'll do is we'll go and create another branch now. Let's say maybe I'm working on a, my friend also has a list of movies, and he wants to help me out, right? So what I'll do is I'll probably go and say git branch, and I'm gonna say Tom, right? Let's say I have a friend called Tom, and he wants to also help me make my list of movies, right? So I'm gonna do that. Now if you see git branch, what do we have in git branch? There you go. We have two branches. We are still on the master branch, but at least we can see that there are two branches. Sweet. Let's also see what would have happened here. Just because we created another branch, you can see that particular information also is visible here. And if we do a cat for that guy, let's see, let's cat the Tom file, right? What is the cat? Let's do, instead of this guy, let's do Tom, and there you go. It's still, though, because we created a new branch, which is Tom, right? But that guy also is referencing to the same commit, because we created it just now, right? And it will always refer to the latest commit. So you can think of it this way, right? So we've got Tom here, right? And he's also referencing to the same commit as the master, because both of them are right now in the same state, same snapshot state, which is totally fine, right? All right, so we have done that. Now what do we do is there's one more thing which I also want to show you guys. You would have seen there is a file called head here. What does that mean? So we talked about branches. We talked that branches are nothing but references to the latest commit, right? Where you're creating the branch, right? But there's another file called head. Now head is something which tries to track the current branch, right? Because you might have, in a big repository, you might have multiple branches. So you need someone to track it for you. You need someone to track that this is the current branch, right? So head is the one who's going to do that. And how do we see head? Let's go back and see. So we'll do again a cat dot get sorry, .git, and we will, I think we can do directly head, right? There you go. See, right now the head is referencing to the master, right? So in our diagram, it's basically going to be here. Sorry, I think I misspelled that. Head, right, is over here, is referencing the master right now, right? Because like I said, the difference is master and Tom are the branches. You can have a million branches like that, but you also need someone to track and tell you that which branch you are on currently, and that's what the head does for you. So it's just a reference for a branch. So if I think I deleted that what I've mentioned earlier, but the last thing which we talked was branch. Now head is nothing but a reference to the branch, right? Or let me just write this. Head is reference to a branch. Branch is a reference to a commit. Commit is a reference to generally a tree, and tree is a reference to a blob or maybe another tree, right? This one we are just building as and when we are studying this, right? So that's pretty cool. All right, cool. So what do we do next? Now what I'll say is I would probably, let me go to so what we'll do is where are we right now? We are in the master branch, right? So in the master branch, what we'll do is we'll go and probably change something, right? So let's go to what do we do? So we'll go to probably, let's do nano, and which file we are going to change? We want to change this genre, and let's probably go to the superhero file which we have, and let's add something, right? We had just mentioned it as superhero before, but we are going to add maybe Iron Man, right? Let's say Iron Man is a great movie, right? And I want to watch that, right? Or maybe Black Panther, whichever you guys like, right? So yeah, so I'm gonna just add Iron Man here, and I'm gonna say Control O, Control X, right? There you go. So we have changed this particular file now, right? We have changed the file. We have added Iron Man because that's a movie which I want to watch, right? So I've added that to my list. So as soon as you do this, obviously the next things to follow would be just check Git Status. There you go. It is telling me, okay, let me read that DS file, clear screen a bit. Yeah, there you go. So it's telling me that I modified the file, which means I really need to go and add this guy, right, which is genre superhero, and let's also right. So we have done some changes, and we will have to next commit it, right? So let's commit it. So when we are committing it, we will have to put in some kind of a label. So I'm gonna say we added a superhero movie, right? We added basically Iron Man. So let me write that. Right? We have added. Sorry, I didn't spell it. Okay, there you go. We added Iron Man. All right, that looks good. So we can do Git Log. And there you go, we have the third commit visible now, right? And let's see what would have, so you see the third commit. Let me write down the third commit here. So the third commit is over here. Okay, I'm not going to put the arrow mark yet. I'm just going to write the third commit, which is 71C2. That's the third commit, right? Now let's go and check what would have happened in this third commit. So I'm going to do Q, and I'm going to do git cat file. Let's try to print this guy. There you go. Pretty similar to what we have done before. It is referencing to a new tree. I'm not going to draw the tree and stuff, right? We have already seen that part, but I want to concentrate mainly on the branches side of it, right? So you see it is referencing to the previous commit, so I can now peacefully go and put this arrow mark, right? That's good. And let's also see what is there in that master which we saw earlier. So let's do .git and refs, right? What was there inside this heads, right? And the other one was master. There you go. So in the master, you can see now it is referencing to the latest commit, which is 712C. So what can we do? We can go and erase this guy from here, right? So the master seems to have moved. Where has he moved? He has moved over here. Sorry, right? The master has moved here, right? The master is referencing this commit now, right? Let's see what would have happened to my head file. So we'll do .git right? There you go. And you see the head is still referencing the master, right? Head is still referencing the master, which means, right, so this guy, can I just control? Yeah, there you go. So there you go. This guy head has basically moved to the master now, right? So this is very important to note. What happens is whenever you do some changes in the branches will, the reference of the branches basically will move to the latest commit, but the head, which is the current, the reference to the current branch, that will just piggyback along with the, it is not going to change anything unless you change the branch. It's still going to reference to the master, but the master would have moved to a different commit. So subsequently, when head is referencing to a different commit, ideally. Right? So always remember, master is moving, head is not moving. Head basically moves along with your, or basically will be still pointing to the guy or to the current branch, right? Awesome, cool. Now what do we do is we'll do something fun. So we are right now in which branch? We are in the master, right? So let's go and let's move to the other branch, which is the branch of the Tom, right? So what is the command for doing that? We can say git checkout and we can say Tom, right? So you can see the message here, it is telling me that it is switched to Tom. We can also do git branch to see that, right? There you go. You have the star with the Tom. Sorry. Okay, give me a second. All right. So just because I did the git checkout Tom, right? There are actually two interesting things which has already occurred in the background, and I want to really point that out, right? One thing is obviously, git branch, like I showed you here, right? It's obviously pointing to Tom, but that's fine. But let's look at what has happened in my head file, right? So it's .git, and let's see head. There you go, right? The head is pointing to Tom. So this is point number one. This is what happens, right? So my head file is, head is basically, sorry, no, the head is basically pointing to Tom. So let's do that. So let's probably grab this guy, just like how we did earlier. Let me grab him. Probably not. Once again, let's try that. Yeah. Let's grab this guy and let's put him here for now, right? So the head is pointing to Tom now. So that's one thing. The other thing is very interesting, right? So let's do a tree here and let's see. So when you did a tree here, let's probably do superhero maybe, right? Or what was the file we changed earlier? I think we had changed index, right? We had changed index in our, okay, let's give me a second. Or maybe I think we had changed, I'm not sure which one we had changed in the just previous commit, right? So I think we had changed the genre, I believe. Yeah, remember we had changed the superhero file here. If you scroll a bit top, we had used nano and we had changed the superhero file to, superhero plus Iron Man. We had added Iron Man, right? In our master branch, we had edited the superhero file and we had added Iron Man. But you see here, because we checked out of that branch to, a branch which is called as a Tom branch, right? Which doesn't have the Iron Man listed in it, right? And that's why you see that, it just has superhero. So what has Git done is, in the background, it has also changed the working area, right? The working area, it's subtle though, it is not very evident because the files, at least in this case, the number of files, all of that is same. So it's very subtle, but still, it's very, very important to notice that. You can see that, in the superhero.txt, you can see the Iron Man doesn't exist because Iron Man is there in the master branch. And, that is the second change. So there are two things which, Git does when you do checkout. Anyway, so this is the current state which we have, which is fine. What we are going to do is, let's probably go to the superhero file here, which is genre and superhero, and I'm going to add maybe something else, right? I'm going to add probably, what do we add? We'd add, let's say Tom is okay with Iron Man, so let's add Iron Man, but Tom also wants to suggest maybe something like Black Panther, right? That's one of my other favorite movie as well. So I'll say Black Panther, right? And I'm gonna say I'm gonna write this down, right? So I'm gonna save that. There you go. We can check if that has gone in successfully, right? There you go. So we've got Iron Man and Black Panther, which is a good thing. All right, so but again we have to, let me clear the screen. Let's do Git Status, and we are yet to add this, so we'll do Git add genre, superhero, and we'll have to do Git commit. -m, and what is the commit label we want to put in, or commit comment maybe, right? We could put a comment saying add Tom's version, right, of superhero, right? So because we are trying to commit Tom's version now, Tom is suggesting that it's not just Iron Man, but Black Panther is also a very good movie, right? So I'm committing that, and there you go, it's committed. So we have committed something, right? And let's do Git log here. There you go, the last log is, or the last commit is seen here, right? So where does this come into play? So this one will basically come into play over here. So what I'll do is probably grab this one a little bit. So I want to tilt it a bit, or probably move it a little bit this side, right? Okay. So the new guy, right, basically comes here, right? And what is the commit name or the commit number? It's basically 868D, right? That's a new guy, right? And let's do it as usual, just like how we do always. So we'll do is, okay, I think I forgot to grab it. Let's grab that again, copy, right? Let's quit, and let's go cat file, and let's print. What is this pointing to? And there you go. This guy is again pointing, the parent is F71 itself. So this guy, so he's still pointing to here. This guy is also pointing here, right? Let me just grab this one and put it here maybe. Yeah, that looks good. So you can see this is what has happened. We just committed something, right? We committed to the Tom's branch, so a new commit was created, but the parent is still, pointing towards this. Let's see what has happened to the head file, right? Is the current branch changed? It shouldn't, right? Let's check that. So git, let's do a cat here, and if you do head, you will see that it is still pointing to my cat head, right? It's still pointing to Tom. That's fine, but what is Tom pointing to? Let's see that. So if you do cat and go inside the Git folder, go to the refs, go to probably head and Tom. There you go. You can see this Tom. The branch Tom is pointing to the latest branch, latest commit here, which is 868D. So we will have to move this guy now. So let's move him. So we have to move obviously Tom. So let's move Tom here, from here to here, right? And let's also obviously, because when Tom moves, your head also moves along with him. So that's where, there you go. That guy has moved as well, right? So that's basically what I wanted to show here, right? So you can see how every time you do a commit, or how that this is basically what happens. I mean, when you check out, you're obviously doing two things. One is your head is going to point to the new branch, and your working directory will suddenly change to the branch, to the branch you're working with, right? And then inside that branch, when you commit something, it again follows the same procedure which we saw earlier, right? The head basically piggybacks with the branch, but the branch is the one which will be referring to the latest commit, and that's how it flows around, right? So that's pretty cool. Now what we'll do is we'll probably check out again, right? Or what do we do now? Let's see. Yeah, let's check out. Let's check out of let's check out to our master, right? Let's check out to the master, right? So when you check out to the master, what would have happened? This guy, which is over here, let's grab him. So this guy would have come over here, right? the head is basically pointing to the master now, right? The rest everything is same. It's just that when we check out, the head is pointing to master, and obviously my my working directory would have changed, which means if I do a cat to my genre and superheroes, you'll basically see only Iron Man. You don't see Black Panther, because Black Panther was in the Tom's branch, right? But what I want to do is, I'm happy with what Tom is suggesting, right? And in my master branch, I want to kind of like, let's say, let's use the word merge, right? I want to merge whatever Tom is suggesting into my master branch. How do I do that? It's pretty simple. So I'll have to do git merge, and I'll have to put the branch, which I want to merge into, right? So I want my Tom to merge into my master. So I'm going to do git merge Tom. There's some issue, right? So we get some issue. There is some conflict, right? Why is this conflict? Because Git is telling me that you also have a superhero file or superhero text right here, and Tom also has it, right? So when you're trying to merge, which one do you want to use, right? So we'll have to resolve this conflict manually, right? We can do a git status here to quickly see, and there you go, right? It'll give more information about the conflicted file, right? Both of them are trying to modify this particular, or when you're trying to merge, this is the file which is there in both the places. So we have to manually try to fix it. So how do we do that? Let me clear the screen a bit. Which is the file in the tree? It's basically nano. Let's do nano. Let's go to which one? Genre and the superhero. This is me manually fixing the conflict, right? Right, there you go. So Git has added this nice marks for me, right? It's basically telling me what to do. So I'm gonna just do this. I'm gonna just remove that, right? So this is how you resolve the conflict. You basically keep everything which is needed for you, and the rest of the stuff you can remove it, right? So that's how you resolve it. So this is what I want. So I'm gonna say Control O, and yeah, I've saved it, right? Now let's see git status. What would have happened to git status, right? So this is fine. You have unmerged paths, that's fine. So what I'm going to do now is I'm going to manually add it, genre and superhero, right? There you go, it's added. I'm going to say git status again. All of that errors would have gone off, and now we will do a git commit, right? So I'm going to do a git commit. When I hit this, you see it is already adding a comment, right? It's already adding a comment called merge branch, so I don't have to add a manual comment, but if I want, I can do that as well. But in my case, I don't have to, so let me just right? So there you go, it committed. So git commit, and you see merge branch stop, and it has been committed now, right? So we can do again a git status if you want, and you can see nothing to commit anymore. We have successfully committed, right? Let's go and check this one now. Git log. What has happened to git log? There you go. We were referring to 8680 before, right? That was the Tom's branch, and we seem to have added a new commit here, which is the C7 one, right? Because we have merged it, so there is a new commit which has been created, right? And so maybe let me add that guy here. Let me add that new commit here. So that's going to be C71F, right? Those are the first 4 characters. All right. Now let's investigate what is there inside this guy. So we'll do git cat file print, and there you go. But interesting thing, this is why I was telling commit can have 2 parents. Right now, because we merged the branch, right? We merged the Tom's branch onto our master branch. You can see there are 2 parents, and these are the 2 parents. 71C2, which is here, right? So this is one of the parent, and the other parent is here, right? Do you get that? Looks fine. I think it looks fine, right? And excuse me. So we've got that done. That's pretty cool. And what do we need to see here else? You can see the comment also is visible. Merge branch, that's visible here. That's fine, right? I mean, I could have added another comment as well, but that's mainly it, right? So do I need to show you guys anything else here? Let me see. Let me think. Give me a second. All right. There's one more thing which I probably missed here is, I mean, once you merge, obviously your master and this thing also has to move there, right? Because you merged on your master branch. So the new commit, your master is first going to move to the new guy over here, right? And your head is obviously going to piggyback and follow as well, right? So that's how it works. So now the master is here on this guy and the Tom is here. Okay. Now the other thing is, which since we are already here, what I want to show you here is pretty interesting, right? What I want to show here is, let's do one thing. So I'm on Tom. I mean, I'll go to Tom now. Let's check out to Tom, right? So I've switched to the Tom's branch. Let me clear it. Okay. But what if I want to merge Tom? I want to merge master into Tom, right? The master has the latest stuff now, but I want to merge master into Tom, right? So if I want to do something like that, it really doesn't make much sense, at least from a point of view, because I mean, you want to get, let's say you want your Tom's branch to be also up to date, right? But you see, you don't have to literally create any new blobs entries, because master is already there. You're just replicating it. And what is the first rule of Git? It doesn't duplicate any existing trees and blobs internally, right? So if I try to do this, let's see, Git Merge and master, right? Keep in your mind, master is already having all the data, all the content, everything perfectly updated. We are just merging that guy into Tom. So when you're doing that, Git internally doesn't have to create something new, right? So you see, that's why, there you go. See, you see a text called fast forward here, right? So the idea here is Git will not create any new commits for this, right? So it's going to be, if you see Git Log, right, you can see the topmost commit is still the C71F, right? It has not created anything new, right? So that's what I wanted to convey here. So what has happened now is our guy Tom here, also is pointing to this particular commit, right? The latest commit which is completely merge of both the branches, right? So that's very important. Fast forward. Just wanted to put it out there. Sweet. What I'll do now is, let me just grab this one and push it a bit down because I want to do some stuff on top of this here, right? So let's get this guy down maybe, right? So we are here, right? What I want to conclude this particular video, I think maybe, is to talk about a very interesting case called Detached Head. Now that's a very useful case as well, which probably you might not be using a lot on a day-to-day basis, but it really makes sense to use it. So let me try to explain. So let's check out back to master, right? So we are back to master, right? We are here, and the latest commit we know, which is C71. We can double check that as well. Git log. There you go, the latest commit. Now what I'll do is, I'm gonna take the latest commit. I'm gonna copy this guy, right? And what I'll do is, I will do a git checkout to the commit directly. I mean, I was always using git checkout with the branch names, right? Either master or Tom. But this time what I'm going to do is, I can directly check out to that particular commit, right? Let me do that. There you go. Now, once you do this, we can go and check what has happened to the head, because we have to move it, right? Let's see where he has gone. There you go. The head is pointing to, it is no longer pointing to the master or Tom, it is pointing to the commit directly. Okay. So, I mean, as of now, this is perfect. Both of them, the head is also pointing here, master is also pointing to the commit. Or maybe to make it more evident, I'm going to just grab this guy, I'm going to place it here for now, right? Cool. So, head is also pointing here, master is also pointing here. Okay. Now I'll just get a bit, this gets interesting, right? What I'm going to do is, I'm going to do nano and I'm going to go inside that superhero text file, and I'm gonna probably add something. Let's say in this state I'm adding one file or one more superhero, which is, say, I don't know, maybe let's add Captain America, right? There you go. I've added one more guy, but in this particular stage I'm gonna do Control O, Control X, right? I'm saving that guy, right? Let's do Git Status, right? So here basically your head is behaving like another branch, right? Because it is directly pointing to the commit now, right? So it's asking me to do this. So let's do that. Let's say git add genre and obviously superhero, and I'll say git commit, and I'm gonna say what we added captain, right? We added captain just now, so that's good. So there you go, we've comment. Okay, I think we did not put the flag here, my bad. Right, there you go, we added Captain America. Right, now let's see what is the latest git log. So this is the new latest commit, so we will probably have to do some changes here, right? First let's grab our head from here. Let's wait, Control Z. We'll have to grab just the head from here, so we can grab him and keep it on the side for a minute. Let's go and add the new guy, which is the new commit here, right? Which is basically D842, right? And obviously our head, which is here, is basically pointing to this guy now. Right, I can change the color if I want, yeah. And just like any other commit, this guy also will have the parent commit, which is this one, because we got him from here, right? The master, Tom, all of them are down, right? Our head is basically pointing to the latest commit, right? So I mean, we can check that as well. I mean, if you have a doubt, we could do that. We could just copy this guy. We could do clear and then go to git cat file, and there you go, right? You can see the parent is nothing but C71. We are pointing into the correct one, right? We are no longer interested in what happened in the bottom. Let's just keep that as of now. But yeah, so this is good. Let's go and do one more edit, right? So let's go and do one more edit. So we'll say probably along with Captain America, let's add I don't know which one. I mean, let's go to the DC universe. Probably let's add Batman to this, right? So Control O, Control X, right? That's good. So we have added something else. So we'll do git add, obviously, and genre superhero, and we'll also have to commit this guy. Module, and we'll say added Batman. All right. So there you go. So we have added one more this thing. So let's do git log this time. And this is the latest commit, right? So let's go and do that. So basically we have one more guy, which is 2A, and 1, right? Those are the 4. And this guy will be pointing here, obviously, and we can grab the head and move it over here. So this is what we have as of now, right? The head is basically pointing to the latest commit. So that's okay. That looks good. So sweet. Yeah, so that looks good. All right. Now what I'll do is let's say I check out, right? I check out of this. I check out to the master, right? I checked out to the master, and the master is still pointing here, right? Now the problem here is, how do I go back to because once I check out to the master, the head will be pointing where? The head would have come down here, right? So now how do I ever go back to these two commits, right? So it's difficult, right? So this particular state is what we call as the detached head state. So this is called as, detached head, right? That's what we call this, because see, we have done all these changes, right? And then we came back to the master. Now it's very difficult to go back unless you know the complete SHA value, right? Unless you know the complete SHA value, it's very difficult to get back to the older, state, right? So but I still can save this because I still have the SHA value at least here. So if you want to save this particular, or you want to save this commit, right, you ever want to go back to this commit, the only way to save it is basically git checkout, right? The only way to go to that particular guy, go back to that particular commit, is to go with the value, right? Go with the SHA value. So here, there you go, right? So I've switched back. So I've got my head back here, right? This is what I've done. I got him back here somehow, right? But it's very difficult to remember the SHA value, right? You'll never be able to remember unless you store it and stuff. So the safest way to do is, right, before detaching yourself, put a branch over there, right? Now you can say something like git branch, something like testing, right? I'm gonna say testing, right? There you go. So I put a branch now. Now I can check out to my master if I want, right? But we will always have that branch, right? The testing branch will always be there, so you can anytime go back to that particular commit and you can work on it, right? So that's basically how you can kind of work around the detached head state. Now normally developers use this particular scenario to test certain things, and if you want to test something without actually creating a branch, right, then this is a very good way. Detached head is a very good way. Simply go on committing, testing everything, and then once you're done with all your testing, you can discard that particular, you don't even have to put a branch name, you can completely discard it, because Git, what it does is frequently it will do garbage collection. So if it finds any of these commits which doesn't have any reference, right, doesn't have any branches connected to them, then it will delete those particular commits. So people use that in that way as well, right? They use it for testing, and then when they realize that they have finished the testing, they'll switch back to master or Tom and go and commit it and do the changes over there, and that way these will be lost, right? But if you want to salvage your commit and you want to use it in future, just make sure to do this, right? Go check out to that particular branch and put a check out to that particular commit and put a branch name for that. Like in my case, I put testing, right? So yeah, so now that I've checked out back to the master, basically the final state of this head guy would be basically over here, right? And we have literally created one more, literally what we have done is, as part of the end of the video, we have actually created something called testing over here, right? Which is another branch which is pointing here, right? So that's mainly it. I think I wanted to cover in this video at least. Just to recap, the final thing which I really want to again call out is, let's just try to understand, or maybe let me just see if I can do that here at the top, maybe. Yeah, I think that should be enough. So let's see from the right hand side, right? Blob is the smallest unit that is generally referenced by a tree, which in turn sometimes references another tree. Now trees are generally referenced inside a commit, right? Now commit can reference one tree or multiple trees. Commit can also reference one more commit, right? So commit, that's what we see here, right? A commit is referencing the parent commit, right? And I'll tell you the significance of that in a minute. So commit can reference another commit, tree can reference another tree, and the smallest unit is blob. And a commit is then kind of referenced by your branch references the commit, and then you have the head which is referencing the branch, right? That's how the whole flow goes about. But important thing is, observe this one, right? The commit referencing a commit, this is very important with respect to tracking history. That is the main job of this one, commit referencing another commit. It helps you to track the history, what is happening, what was the snapshot before and what is the current snapshot. Rest of all the references which are there here, especially tree referencing a blob, tree referencing a tree, commit referencing a tree, all of this is very much needed for tracking the content, right? So this is for history, right? Commit referencing commit is mainly for tracking the history, and the rest of the stuff is mainly for tracking the content, right? So hope that was useful, guys. I wanted to cover almost all the basics which we use on a day-to-day basis in Git. and I wanted to show you guys what really happens in the background, right? When you run all these commands, what really is happening, how the branches are talking to each other, or how the branches, how you can merge the branches, how you can check out of the branches, how you can do all the git add, git commit, and what is the actual significance of that, right? Hope this was useful. Thanks a lot for watching and have a good one. Bye.